Hey guys, so the folks at home are going to do the lab that we're also doing in class. Now, if you can somehow link up with somebody who's in class doing it, that might be better because you might have some input in what's going where, but that's probably going to be impractical. So I'm going to have after this intro, an actual video of me hanging the weights. And what I want you to do is pause the video before I hang up the weights so you can try to figure out where they should go so that the beam will balance. Okay, this is the handout here, and the front side just goes through what I did in the last video about what torque is and how it works. Now, what we want to do here is keep the math as simple as possible, because this is supposed to be an intuitive exercise that gives us a gut level understanding of how torque works. So don't worry about force in newtons, just keep it in grams. 200 grams is fine. And don't worry about distance, the lever arm in meters, just do it in terms of holes. So 200 grams hanging 2 holes out from the fulcrum, that would be 400 units of torque. And I'll demonstrate this so you'll know what I mean, but keep the math simple. We want you to be able to do this in your head. And our goal is for you to be able to predict just kind of intuitively, if I hang a big weight close to the fulcrum, well, then I'm going to have to hang a small weight farther out and about that far out to make it balance. And then you can kind of quickly do the math in your head, make it work, and get the balances. Okay, so go through them in order, calculate the torques on each one, and then move on to the next one. When we get to the end, try to do these challenge ones down here at the bottom. I'm not going to demonstrate these last two, but see if you can figure out how they work. Okay, good luck on this and have fun with it. Hey guys, I'm going to walk you through the torque lab. This is kind of our last resort here. If you can join up with somebody else who's actually doing the lab in class, if there's a way to technically make that work, that's probably preferable because you'll be able to give some input into how we're constructing these things. This one, I'm basically going to have to pose the question, let you pause it for a moment to try to come up with a plausible answer, and then I'll show you one. And that's kind of the best we can do. That's fine. So the setup here, this is for the hanging out lab. Yep, hanging out, there it is. And you have a copy of this on your in the classroom. The front side explains torque and the concept of torque, but you've already seen that video, so it's just kind of a reminder for you. And the apparatus is set up, and that's what the first couple items here are about, is just setting up the apparatus. So the heart of this is to figure out how to hang the weights that are shown in a way that the torque on each side of this fulcrum, so the torque is the same on both sides, so the thing will balance. That's what we want to do. Now, the first one's fairly straightforward, so I'm not going to do it. I'm going to start up with number 2, because the big question that students usually have is, what do you mean show the work? What do I actually have to show here? So I'm going to start with number 2. And as you can see, number 2 is we're trying to balance 200 grams with 100 grams. 200 grams with 100 grams. And there's a couple of different ways we can do this. So see if you can think of one, but I'm going to show it fairly quickly because we have it. We can have the 200 gram hanging here, 2 holes out, and it will balance if we put the 100 gram 4 holes out. As you can see, now it is steady. We could do this another way too, but this is what we have here. So we found a way to balance it. Now, what do I want you to show for the work? I want you to show a calculation that shows the torque on each side of the fulcrum here. So we have 100 grams, 4 holes out, 1, 2, 3, 4. So that's 400 units of torque, which are trying to tilt it this direction. That's why the arrow is curved this way. And then on this side, we have 200 grams, which is 2 holes out. And 200 times 2 is also 400. So I'm showing the work that the torque on this side is the same as the torque on this side. That's what I'm looking for. Okay. Now, you may have thought of another way to do this. We could put the 200 here and the 100 here. And in this case, the torque on each side is 200. 200 times 1 is 200, and 100 times 2 holes is 200. But the torque is the same on both sides. Okay, number 3 is 200 grams balanced with 600 grams. So we're going to take 200 and 600. All right, pause the video. Think about ways that you can do this. And sometimes there is more than one way to do it, but that's fine. So pause it. And when you have a solution, then go ahead and go with it. Okay, so this balances. We have 600, one hole out, that's 600. We have 200, three holes out, that's also 600. So 600 balances 600. Number 4 is to balance 1,200 grams with 800 grams. That's 1,200 grams. That's 800 grams. Now I'll give you a hint on this one if you're thinking about it. Pause it if you don't want the hint. Okay, here's the hint. Think of the lowest common multiple of 12 and 8. And 24 is really the first number that both 8 and 12 go into evenly. So work from 24, see if you can figure out how to make 2,400 units of torque on each side. And there we go. We have the 1,200, 3 holes out. I'm sorry, the 800, 3 holes out, and the 1,200, 2 holes out. Next up, we have number 5, which is balancing 200 grams on one side. Let's see, this is our 200 grams on one side with two 200-gram weights on the other side. Okay, so think of a way to do this. Oh yeah, and the key on this one is that we can't hang them from the same point. Okay, we have to hang them from different holes on each side, and we can never hang them from the center hole because there's no torque there, and that's kind of cheating. We try to figure out a better way to do that. Okay, so 200 grams on one side with two 200-gram weights on the other side. So go ahead and pause that. And now we'll show you the way. All right, there it is. 1, 2, 3, 4 holes, 1 hole, and then 3 holes. And the way this looks when you show your work is 200 grams, 3 holes out, plus 200 grams, 1 hole out, is equal to 200 grams, 4 holes out. 600 plus 200 equals 800. That's it. Okay, next we have a 200 grams with 2 100-gram weights in different places. So we have a 200-gram weight with 2 100-gram weights. Think about how to do it. There's a couple on this one. Pause it till you have an idea. Okay, here we go. And there it goes. So we have 3 holes out, that's the 200, and 2 holes out to a 100, and 4 holes out to a 100. There's another way we can do it too. We can move all of them in by 1, and that will also work. So this also works. This is 200 grams, 2 holes out, and 100 grams, 1 hole, and the other one 3 holes. Next, let's see, number 7, we have 1,000 grams with 2 200-gram weights in different places. So we're going to go with 1,000, 1,000, and 2 200s. All right. So think about it and see what you come up with. Pause the video, play it when you have a solution. That works. So this is 1,000 in the first hole, 200 in the second hole, and another 200 in the third hole. Next, we have 1,000 grams balanced with 500 grams and 250 grams. Okay, so we have 1,000 grams balanced with 500 grams and 250 grams. All right. Thousand grams, 1 hole out, 500 grams, 1 hole out, 250 grams, 2 holes out. There may be another way to do this too. Let's see. Basically, what I did there was I moved every weight so that would produce twice as much torque. So 2 holes instead of 1 for the 1,000, 2 holes instead of 1 for the 500, 4 holes instead of 2 for the 250. Double all the distances, the torques will still balance out. All right, that brings us to the challenges. 500 grams versus 200 and 200. Actually, I'm going to let you do the challenges on your own. As you can see, what we're trying to do is do the math kind of quickly in our heads so we can figure out how much torque is on each side so that we can make it balance out. And so I'm going to let you do the 2 challenge ones. Please do try to figure out how to make it work. They're all possible to do. Yeah, do with it and try to have some fun. Okay. Someday you may be able to come back to school full time, and if that happens, when that happens, we can get this apparatus out and you can play with it, because doing this hands-on really does help us understand torque and get a gut feeling for how it works. Okay, thanks for your time, and we will see you next time.